IUPAC system. IUPAC system. This is International Union of Pure and Applied Chemistry system. This is the most extensive and the most comprehensive way of naming organic compound. Be it the type of functional group, whether alcohols, carbonyl, ethers, esters, carbohydrates, alkanes, alkenes, alkynes, mention it whatsoever. Now, there are rules that will make us remember what the nomenclature of what this organic compound. First thing first, I won't write the rules because most students are fond of forgetting the rules. But once I write the compound on the board, I tell you the rules that is applicable. Now you remember. Take a look at this, my friends. Take a look at this. What's the IUPAC name? Let's count the carbon atoms. Remember, always count from what? Long continuous chain. Count the what? The longest continuous chain. Now, ladies and gentlemen, where should I start from? Here or here? That's where rule number 1 comes in. The first rule says, always start your counting from what? The lowest low count. What is the low count? The point at which the what? The functional group that determines the compound is being located. It will be very wrong for me to start here. Why is it wrong? Look at it. If I start here as carbon 1, 2, 3, 4. 1, 2, 3, 4. 1 plus 2 is what? 3. 3 plus 2 is what? 6. But if I start from here, 1, 2, 3, 4. 1 plus 2 is what? 1 plus 2 is 3. So it is very, very convenient for me to what? To start from here. Even if I did not remember this rule, I know that the functional group is close what? Is closer to this side than to this side. So I will start counting from what? From this side. 1, 2. I will say, okay, 2. 1, 2, 3, 4. This is what? Boots. Okay. I will say it is butan, 2 or. The hydrazine functional group is located on what? Carbon 2. That is why I see 2O. Butan is what? 4 carbon atom. In another way, I want to use another example to tell you another rule. Now look at this. How do we name this compound? How do we name this compound? We all know that this is the longest continuous chain. We all know that this is the what? The longest continuous chain. But there is a functional group present in this compound, and it is not located in the what? In the longest continuous chain. We are supposed to start from here, but because of what? We don't want to what? Leave this functional group out. We will start from here. Rule number 2. Always start from what? The side which have the functional group. or give preference to the what? To the side which possesses what? The functional group. Or give what? Give space to the side in which what? Possesses the what? The functional group. I will start from here. I won't start from what? From here. Ladies and gentlemen, I will start counting from here. Even if I have to start counting from here, some students will say 1, 2, 3, 4. It is wrong. Why shouldn't I start from here? Because the functional group is closer from here to here. Alright, 1, 2, 3, 4. In other words, if I still count here, I am still saying the same thing. 1, 2, 3, 4. But in all notions, you must start from what? The place that have what? The functional group. What's the name of this? 1. Alright, 1, 2, 3, 4. 1, 2, 3, 4. Now, what happens to here when we start counting here? This will become what? A substituent. This will become what? A substituent. What's a substituent? A substituent is an alkyl group that is being attached to what? An organic compound. For example, I will refer to this as what? As an alkyl group at this point. I will refer to this as what? An alkyl group. What type of an alkyl group is this? This is what? An ethyl. This is what? An ethyl. Why? Because a hydrogen atom has been what? Replaced by what? A carbon. And we call this what? An ethyl. 1, 2. I will say 2 ethyl. 1, 2 ethyl. 1, 2, 3, 4. Butan. 1, 2, 3, 4. Butan. 1 ol. 2 ethyl, butan what? 1 ol. The hydroxy functional group is what? Located in what? Carbon 1. Then we have what? A substituent at what? At carbon 2. What is the name of that substituent? An ethyl substituent. Then 1, 2, 3, 4, a butanol what? Group. Then we have what? A hydroxy group in what? In carbon 1. Alright, it is very easy, but I want to show us another one. I want to show us something that is a very bit hard. This is Chem 122. Take a look at this. Take a look at this. Ladies and gentlemen, we are having 2 hydrogen group. We are having 2 hydrogen group. What does that tell me? I am seeing a dihydric alkanol. I am seeing a dihydric alkanol. I am seeing what? A dihydric alkanol. Where should I start from? Where should I start from? Should I start from here or I should start from here? Ladies and gentlemen, always start from what? Where the hydroxy group is closer to the what? To the outside. Look at this. The hydroxy group is closer to this place than from here to what? To here. Even if it were not to be like that, let us count the what? The number of locants. 1, 2, 3, 4, 5, 6. We count the number of locants. 1, 2, 3, 4. 1, 2, 3, 4. Let us add all of them together. 1 plus 2 is 3. 3 plus 3, 9 plus 4. That's what? Equals to 13. That's what? 13. But let's start counting from this side. 1, 2, 3, 4, 5, 6, 7. We can see that whenever we add all of them together, it will be more than what? 30. So 30 is the lowest possible locant here. So therefore, I will start counting from what? From this side. I am not doing this to show you nomenclature alone. I am doing this so that you remember the what? The rule. always start from the what? The points that have the lowest what? Possible number of what? Locants. Always starting from where has the what? Possible number of what? Locants. Alright, let us move forward. Welcome back. Now we'll be talking about the properties. Properties. Whenever we talk about properties, whether organic, inorganic chemistry, we are talking about the behavior. In other words, we can also say what? They are characteristics. They are characteristics of what? Of that compound. Now, what are their properties? There are two types of properties in chemistry in general. We have chemical. We have physical. Now we will be talking about the physical what? Properties of what? Alcohols. Now, what are properties of what? Alcohols. Now, it is very simple to what? To know the properties of alcohols. Remember, when we started this class, I said that this is an alkyl group and this is what? A hydroxyl group. Now, if I remove this alkyl group, I replace it with hydrogen, I will have something like this. I will have something like this. In other words, this is the same thing as this. And we, of course, we know that what? This is what? Is water. So since one hydrogen atom has been replaced by what? An alkyl group, we will agree that the physical properties of water will be similar to that of what? Of alcohols. Number one physical properties I would like us to know this afternoon is number one, boiling point. Boiling point. Ladies and gentlemen, the boiling points of alcohols, increase with increasing numbers of what? Carbon. It increases with what? Increasing numbers of carbon. For the sake of those that will be watching this video in the University of Benin, I want you to know this. The more the carbon atoms, the higher the what? The boiling points. The more the carbon atom, the higher the what? The boiling point. The lower the carbon atom, the lower the what? The boiling point. Ladies and gentlemen, I'd like us to know one concept in what? Organic chemistry. Boiling points. Boiling points is not the same as melting point. It is not the same, and it is not the opposite of what? Melting point. They are not the same, but they are not the opposite of each other. But boiling is the opposite of melting. There is difference between boiling point and melting point. There is difference between boiling and what? Boiling point. There is difference between melting point and melting. This is not the opposite of this. Ladies and gentlemen, as the number of carbon atoms increase, melting points also increase. As the number of carbon atoms increase, boiling points also increase. So boiling point increase with what? Carbon atom. All right. Let us look at what? Solubility. Solubility. Let us look at what? Solubility. What is solubility? Solubility is what? The property of a compound to dissolve in what? In a solvent. What is this solvent we are talking about? We refer to solvent in chemistry as what? As water. The ability to what? Dissolve in what? In a solvent. Ladies and gentlemen, since hydrogen bond is present in water, and we also say that water is covalent in nature, since they have similar what? Physical properties, I am convinced that what? The solubility of what? Alcohols will be similar to that of water. Since hydrogen bond is responsible, I think hydrogen bond will also be responsible for what? That of what? Alcohols. In summary, the more the carbon atoms, the lower the solubility. The more the carbon atoms, the lower the solubility. Hear me, the more the carbon atoms, the lower the solubility. So carbon atoms in an alcohol determines what? The solubility. Now, I want to talk about volatility. Volatility. What is volatility? What is volatility? The ability or the rate at which what? A compound evaporates at a what? A specific temperature. Do not forget that evaporation takes place at what? A specific temperature. Now, volatility, the ability of what? A compound, organic compound specifically, to evaporate with a specific temperature. And we all know that boiling point has something to do with what? Evaporation. Which deals with what? Volatility. What am I trying to say here? I am trying to tell you that the number of carbon atoms, not only alcohols, the number of carbon atoms determines the boiling points, the solubility, the melting point, and the what? The what? Solubility. I also like us to understand that the number of OH, determines the what? The solubility. The more the OH, the more the solubility. The more the OH, the more the what? The solubility. Why do I say this? Why do I say this? I say this because water has hydrogen bond, and therefore this functional group has hydrogen bond. This functional group has what? Hydrogen bond. Then the more of this OH in that compound will increase the what? Will increase the solubility. It will also increase the what? The boiling points. But it will not increase the melting points. Hear me, it will not increase the what? The melting points. Rather, it will decrease the what? The melting points. But that does not mean that boiling point and melting point, they are opposite of each other. In fact, they are not opposite at all. They are what? They are not opposite. I like you to know, hydroxy functional group affects boiling points. Hydroxy functional group affects melting points. But the more the hydroxyl, the lesser the melting points. The more the hydroxyl, the higher the boiling points. The more the hydroxyl, the higher the solubility. The more the hydroxyl, the higher the what? The volatility. Now, this will bring us to the end of the class. I believe with this, we can understand the what? Physical and the physical what? Properties of what? Of alcohols. Alright, we have talked about the physical properties. We have talked about what? The characteristics, behavior. So, in our next class, we will be talking about the chemical properties. We will be talking about the what? The reactions. Most importantly, you should not miss the reactions. So this is the most important aspect of what? Of this video. Please do not miss out. Stay tuned to what? Austin Achievers.